All right. Greetings, all you wonderful people. We're going to go ahead and get this started. So what we're working on today, by the end of this lesson, you will be able to apply factoring to solve quadratic equations. Now, this is actually going to be for another lesson. For now, I'm going to kind of ease us into things, and we're actually going to review some factoring. So I know, well, Algebra 1 does have some factoring in it, but I also know that that was quite a while ago, and with all the crazy stuff going on, I know, people generally don't have time to remember everything. So we're going to go ahead and do this review first. So factoring, if you remember, there are a couple of things that we could do for factoring. There's actually a couple of different cases of factoring. The first one is kind of an easy one. We'll get to that when we start our example, but I want you to know right now, the first thing we need to do right now, we also used when we were converting to vertex form, and that was the one where you had to make two parentheses and then fill in the numbers. So how you would get those numbers is going to be the exact same way, although since it's not going to be perfect square trinomials, we are going to have to do a little bit more work. And the examples are going to be a little bit more difficult, but I wouldn't say it'd be like anything to worry about. So what you got to do is start with FOIL backwards, so the word FOIL, but it's going to be backwards, and it sounds like LOIF. And I call it the LOIF method, so it's much easier to remember, so that you have a much easier time remembering it. So two numbers, and it stands for starting with the last number. So if you start off with a group of numbers, and usually they might look something like this. Well, actually, I have it right here. So you would look at the last term, which in this case is our C value because it's in standard form, and you would think of two numbers that would multiply to get that C value. Also take into consideration the sign. Now, with those same two numbers that you use to multiply for C, will those two numbers add up for the middle number, so our B value? And also pay attention to the sign as well in this case here, because those signs do make a difference. They can change, because like if you get an answer of 5 when it was supposed to be -5, well, the number is the same, but the sign is wrong there, and 5 and -5 are not at all the same thing. They're just completely different numbers. So you have to pay attention to that sign. And then the last step is actually going to be the first number. So we're going to look at our A value here in our standard form. So what two numbers could we multiply to get the first number? Now, in this case here, there's going to be, I think most of them are going to be kind of like an easier step where you would, gosh, I lost my thought. If it has an A value, you're going to have to do a little bit more work. And in that case, you might just have to resort to trial and error. And if you ever have to resort to trial and error, please don't be afraid of it, okay? Like, life is nothing but trial and error. You try something, it doesn't work, change a few things, try again. That's what you do. Almost nobody in life has really just gone and ended up where they were, all right? Usually it's going to involve trying out a few things, going to a few different schools and whatnot, right? So let's go ahead and move on to our first type of factoring, and that is greatest common factor type factoring. And with this method here, I also call it reverse distributive, because everybody should be familiar with distributive property. So just as an example, if I had three times the sum of A and 1, right? When we multiply it out, we got to multiply both terms by 3. So that means 3 times A, keep the sign the same, and 3 times 1. So you would get something like this. But we're actually going to be doing the same thing, but backwards now. All right. So it's going to be the exact opposite. So instead of multiplying the inside terms, we are going to be trying to take them out. So let's go ahead and start with our first one right here. So let's look at 12 and 18. And what's the largest number that I can divide 12 and 18 by? So you might be thinking, well, we could divide them both by 2, and you would be right because, well, 12 can be divided by 2 and 18 can be divided by 2. But if we did that, we would get 6 and 9. So 6 and 9 also have another common factor, and that would be 3. So this tells us that it's not going to be the greatest common factor. In this case, the greatest common factor would be 6. So what we're going to do is we're going to take these two numbers and put them in a parenthesis. In fact, I'm going to do it kind of like this. And sometimes you don't really need to do it exactly like this, but I'm going to put them in a parenthesis so that way I can see that they are grouped together. And I'm going to divide both of them by 6. Now, when we divide, we're losing a number, right? If I said something like 16 divided by 8, right, we get 2. And there's no other numbers. When you factor, you need to keep that number, right? So you gotta not throw anything away. Everything has to be the same. So just like moving furniture around a house, you're not getting rid of anything, you're just moving it around. And sometimes by moving it around, you can get more space, but you're not throwing anything away. So even though we divided 12 by 6, which is 2, the 6 is still on the outside. So the 6 is still part of it. And then right here, in this case, we have K still there, and the minus is still there. Sometimes that sign will change, but usually you'd have to divide out a negative for that to happen. Okay, and now for our second term, we have 18 divided by 6, which is going to be 3. And now it's closed. So in this case here, I think we're actually done. This is factored. Yeah, it's factored. There's nothing else we can do. There are no other numbers we could divide out of any of those groups. Now, you can also check it. So do not be afraid to check these things. If I were to multiply using distributive property, so again, you probably learned distributive property when you were in 7th grade or so, all right? I don't know, it's been a while since I taught grade levels that low. I think it was like 2012 I taught 7th grade. So it's been a while, and they probably changed a couple of things since I was last there. Anyway, where was I? Oh yeah, use distributive property to test it. So if I were to go 6 times 2, that would be 12. K is still there, so you would get 12K. 6 times -3 is -18. So that's how you check it. Just multiply it back out and see if it makes sense. All right, so let's go ahead and do the same thing with this one here. So this is all in a big group. So I want the largest number that I can divide out of 40 and 64. And you could, where's my calculator at now? You could probably play around with it a little bit. So you could take, okay, so let's think of some numbers. So I know 40 can be divided by 4. So you get 4 times 10. 64 can also be divided by 4. Wait, 64 divided by 4. And we get 16. Now, I'm going to go ahead and I already kind of know where this is going to go, but just to show you an example, let's go ahead and say 4. Okay, so we divide both of these terms by 4. So if I divide 40 by 4, I get 10. And if I divide 64 by 4, I get 16. Now look at 10 and 16. They're both even numbers. With them both being even numbers, this means we can take out an even greater set of factors. So if you notice this, if you notice that there are a set of factors that are the same, kind of like when we had here, we divided both of them by 2, right? So just an example, let me go back to this one really quick here. So let's say we did 2, we factored out 2, and we got 6K minus 9. And then we look at 6 and 9 and we think to ourselves, hold on a minute, you could take out another factor of 3. If we took out another factor of 3, we would end up with 6 on the outside, and both of these inside numbers would get divided by 3 until it looks like this. So it's got to be greatest common factor, so the largest number you can think of that will come out. So in this case, it's not going to be 4, so we need a different number to take out of this. So looking at 10 and 16, they're still both even numbers. So that means that I could take out another 2. So 2 times 4, my outside number becomes 8. Now let's go ahead and move on here. So 40 divided by 8 is 5, and 64 divided by 8 is 8. Okay, so now we got rid of the numbers. Now we're not done yet because there's still some letters in there that we can get out of that group. So I have x to the 8 and x to the 4. So if I divide it with when you multiply powers of variables like this, you're actually going to be subtracting them, not really dividing them, because remember, x to the 8 already means 8 times 8, or sorry, x times 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 x, 8 times. So it's already being multiplied. So when you're dividing it, you treat it like it's an addition problem. So think of it this way. That x, there are 8 of them, just like you could have 8 bananas. And the other guy has 4. And we need to take something away from both of them, right? So what's the largest amount that I can take away from both of them? In this case, that would be x to the 4. Now, again, you treat it like you're subtracting. This first guy here, okay, we took an 8, and now he's only left with 5. He had 8 x's, but now he only has 4. Okay, so y, we'll move on to y in just a minute, but the second guy has no x left. All the x are gone. Okay, now let's move on to the y. So looking at the third thing we can take away from both of these, if we imagine these terms like people, they both have a y, and we're trying to take away things from both of them. So in this case, oops, we're going to take a y away from both of them as well. And actually that would leave both of them with no y. Neither of them would have a y in this case now. And again, we can check it by multiplying them back out. 8 times 5 is 40, that's true. X to the 4 times x to the 4 would add to x to the 8, so that's also true. And this y would also move here, so it would look like that. And then the same thing here, 8 times 8 is 64, x to the 4 and y, so that part doesn't actually change. So in this case, this is completely factored. All right, so think of it this way here. So kind of this is a little bit of a short story that I tell everybody when I'm teaching factoring of this type. So we think of distributing as giving, right? So one person, when I have you think of somebody who gives stuff, so think of someone who gives things away. All right, so you probably thought of Santa Claus. Santa Claus on Christmas will give presents away. All right, now we're doing the opposite. We're taking stuff. And I know most of you guys are a bit young for this, but what is a person that takes things away from everyone? An example of that would be like tax people, the IRS. They take things from everybody. Everybody who has a job, everybody who makes money, they are coming to take a little bit of it. Now they want to take enough from everybody. They want to make it seem like it's fair. So they're going to take money from everybody. And they come up with a whole bunch of rules to make sure it's kind of fair. But really, again, they're just taking money from everybody. They want to think, okay, what's the most amount of money we could take from this group of people and they won't get mad. You know, what's the largest money that we could take away from this group of people and they won't get mad. So it's kind of like that. We're taking things. So here we have 3 people, and again, we want it to be somewhat equal. So, you know, we can't just take everything from one person and leave the other 2 alone. Since they're all knowing each other and, you know, they're all in a group, we have to take the same amount from each person. So let's start with looking at the numbers first. So I have 14, 35, and 7. So what number can all of those numbers be divided by? Okay, so they can all be divided by 7, right? So we're going to take away a factor of 7 from all of them. So it's not, we're not subtracting. It's not like take away. We are removing a factor. So like, I'll go down and explain it a little bit later, but let's go ahead and look at the m really quick. So this guy has 6 m's. That guy has 3 m's. and this guy has 2 m's. Now we have to take away the same from all of them. Now you might be thinking, well, can't we take away 3 m's from all of them? Well, no, because this guy cannot pay 3 m's, and you cannot, well, the IRS, well, I don't know if the IRS has ever done this, but you can't really take away something from somebody that they don't actually have. So in this case here, 2 is the most we can take away, because if we take any more than 2, then it's going to be unfair for that guy that, everybody else has to pay more. All right, so anyway, that takes care of the m. Now let's go back. So when I say take away, I don't mean take away in the same way like we have subtraction. I mean, we remove a factor of. So think about it this way. Here I have 2 times 7, because that's how you make 14. And then I'm going to ignore the m for now. So here I have 35, which is 5 times 7. And then here I have, well, 7, which if we think of 2 numbers that multiply to that, that'd be 1 times 7. And again, I'm ignoring the m for now. See how they all have a 7 in them? That's what I mean by remove a factor of. So this 7 is gone, this 7 is gone, and this 7 is gone. And that's why we end up with these numbers. So if I were to multiply 7 times 2, I get 14. 7 times 5 is 35. 7 times -1 is -7. So that's where the numbers in the front come from of each term. The coefficient of each term has a factor removed from it. All right, so let's go ahead and move on to the m's now. So here I have m to the 4, because there were 6, right? And we removed 2. We removed a factor of 2 m's. And over here we have 3 m's, and we take away 2 of them. So that's going to leave us with only 1. Now, when you have a 1 power, you don't need to put that 1 power there, because if you see a 1 power, it's automatically just whatever that is. 1 power is just regular. It just means regular. It just means it's regular. Anyway, let's go ahead and look at this one here. So this one lost its 7, and it lost 2 of its m's. So there's nothing left of this third term. Now, when a term loses all of its factors, it's still going to have 1, all right, not 0. So if you were to put a 0 here, then it's not reversible anymore. If I were to distribute it to go back to this, I can't do that anymore. So you have to be able to go back. So that's why this is not 0, it's 1. Or if you remember, if I were to have something like 7m divided by 7m, that would just be equal to 1. Right? So you can't get to 0 by dividing unless you have 0 to begin with. But anyway, that's a big misconception. I know that's something a lot of students will mess up on, is that they will not put that number exactly. They're gonna replace it with a 0. Anyway, let's go ahead and move on to the next one. So let's go ahead and I'm gonna hopefully I'm explaining this pretty good, because to make this go a little bit faster, because I know some people already know how to factor, and they're probably like, oh man, I have to sit through this again. All right, so now let's do the same thing. So let's look at 3, 5, and 8. What number can I divide from 3, 5, and 8? Nothing. They don't have any common factors. In fact, 3 and 5 are both prime numbers, and they neither of them have factors. Now, sometimes in this case, these people can't pay with numbers, but they can sure pay with letters. So let's look at all 3 of these terms, a square, and a. So they all have at least 1a. So we're going to take a factor of 1a from each of them. Now let's look at the b. So this guy has 2b, 1b, 1b. So the maximum anyone can pay that we can take from everybody is b. Now we just think of what's left. So on our first term, we didn't bother the number, so it's still there. A is gone, because it had 1 and we removed it. B square, so it has 2 of them. We took 1 out, so there is 1 left. Minus 5, and again, we didn't bother the number. There were 2 A's, there's 1 left. There's 1 B, and it was taken out. So there's no b for the second term. The third term, again, 8 is not bothered. And the a and b are gone. So the a and b are gone. So they've been taken out front here and leaving it with just 8. So if I were to and again, check it by multiplying it. If I were to multiply a and b, would I get my original expression back? Would I get my original, what it's written here, back? If it doesn't, then that means you probably missed something, all right? All right, so it looks like we only have 1, 2, 3, 4, 5 more slides to go. And some of these are a little bit more than others. So let's go ahead and go with this one here. So trinomials. So with these ones here, we have trinomials and they're in the specific form. They are in the standard form. So really quickly, that's ax squared plus bx plus c. Add a little bit out. And it looks like all of these are going to be in that form. Now, this is where we're going to use that Loif method I talked about. So maybe I'll just spell it out really quickly right here. So that's like this. So let's look at the last term, 45. Now, before we start, we are also going to start with the sign, because knowing what the sign is going to make things much easier. Now, in this case, there is a positive 45. Now, if there is a positive 45, that means, or any positive, it means that those two bubbles are going to have the same sign. So they could both be positive or they could both be negative. Now, if they are the same, they will be the same as whatever the first one is. So in this case here, it is positive 14. So this means that there are going to be two positives in each of those bubbles. Now, that makes this a little bit easy because now all I have to do is think of two numbers that multiply to 45. And they have to add to 14. So I'm going to start with the bottom of the list. So to make a list of factors, you would start with the smallest number that you could think of to divide 45 by, which is 1. So 1 times 45 is going to be 46 if I add those same numbers. So it's not that. We could try 3. 3 times 15 is how you get 45, but will 3 and 15 add to 14? No, doesn't. So let's try 5. So 5 times 9 is 45, but is 9 plus 5 14? Well, yeah. So 9 and 14 are going to be what we're looking for. 9 and 5. Sorry, 9 and 5. There you go. Now we still need to put the x in there, so hold off on writing this down. So again, 9 times 5 is 45, and that takes care of this L. We also took care of the two inner terms, the outside, inside, because 9 plus 5 is positive 14. And again, these signs do make a difference. And then the last term, the final, or the first number, I'm sorry, is x. So what two numbers can I use to multiply to get x squared? And in this case here, I will have x, because x times x is the only way to get x squared. And if we want to check it, use FOIL. So multiply the first numbers, x times x is x squared. FOIL is O, so the next one is O. 5x inside is plus 9x. So 5x plus 9x is 14x. 9 plus 5 is 45 for our last terms. So this works out, it's true. So don't be afraid to check these, all right? Some of these, now when I teach the Loif method, it's not really, it's easy to remember. It works on most basic standard form trinomials like this, but there are some weaknesses, and that weakness comes from having an a value. And since I'm teaching on this platform here, and I can't really work with people in person, and we probably don't have a lot of time on each of these subjects, I have to kind of go with what's the fastest thing you can learn that will cover the most types of problems. And that would be Loif method. There are some other things. There are AC method is one of them. There is X method, which is another one. There is an old method that I used to call double bubble. So there are some different ways you could solve these, and I'm sure there are some others you can think of too. I know different teachers like to have their own things that they cover. All right, so let's go ahead and move on to number 6 in this case. So I'm going to go ahead and move over here. So start with our last terms, our C value. In this case, it's positive 26. So get into the habit of also including the sign. Now, remember what I said. If it is positive, it's not positive, it means it is the same. And if it is the same, they are the same as whatever the first one was. So in this case, our first operation, so there are 2 operations. Like in this case, it was a plus and another plus. In this one, there's a negative and then a plus, a minus and then a plus. So this means they are the same. This means that they are both negative. So both signs in here are going to be negative. Now again, these 2 numbers also have to add to 15, well in this case negative 15. So think of 2 numbers that multiply to get 26. And sometimes you can just start, thinking of numbers in your head and you'll eventually run into it. But again, if you want to go the method so you don't forget any numbers, start with the lowest one. 1 times 26. Now if I put 1 and 26 together, that would be 27, so it's not that. Now let's try 2 and 13, which actually 2 and 13 might work. So 2 and 13 are going to be the numbers because 2 times 13 is going to be 26. Right? Now, what I mean by they are the same, because this is a positive 26. There's 2 ways to get positive numbers. You could have 2 positive numbers like positive 9 and positive 5 multiply to 45, or you could also multiply 2 negatives. Negative 13, negative 2 will multiply to positive 26. Now, they also have to combine to make negative 15. If I had negative 13 and negative 2 and I put them together, I will get negative 15. So these are the numbers that we have. So that takes care of our OI, the middle terms. And then the first term is W. So I'm going to go ahead and just put a W here. And it looks like we are actually done with this one here. And again, check it by foiling it out, because sometimes, even though you think you did the right thing, sometimes a little tiny thing's going to mess up. And if that's the case, you might need to try something like different signs or different numbers, or maybe just try the whole thing over again. So anyway, let's go ahead and move to the next one. And again, the last number in our trinomial in this case is negative 48. Now this is different because the other 2, in fact, all of the ones, including the ones from the last 2 lessons where we were working with perfect square trinomials, were all plus as the second operation or the last term. So this is the first one we've had where there is a subtraction going on. And when there is a subtraction going on, that means the signs in these bubbles are different. So I don't know which one's which. So let's just go with a plus and a minus. And in this case, we don't need to look at the first one. We don't care what the 2C has. It could be plus, it could be minus. Right now, we don't care because it's going to be different. Now, with this way here, there's a couple of things that are going to be missing. So I'm gonna write out that list that I was talking about. So 1 times 48. Next one would be 2 times 24. And I'm going to write it out because otherwise it'd be a lot to talk about. And then 48. So we're trying to make a list. So 48 times, or so what can I times by 3 to get 48? So that'd be 16. And I'm trying to find numbers that have a difference of 2. Meaning it could be, well, for now, let's just look for, so in this case here, these have a difference of 13. This one has a difference of 22. This one has a difference of 47. So let's try 4. So 4 times what gives me 48? And if you're not sure, just take your calculator and divide it by 4, and that would be 12. Let's try 6. So 48 divided by 6, and that's going to be 8. Now look at this one right here. See, they have a difference of 2. So that means 6 and 8 are the numbers that go in here. But the thing is, which one is going to be the positive? Is it going to be positive 6 or negative 6? And whichever one it goes into, the other is going to have to take the other sign. So we're in a kind of a dilemma now. Now, here's the other clue. The OI, the inside part, is going to be the one that tells us which sign it's going to take, which in this case, it's positive. And right now we don't care about less than or greater than, okay? Which one has the higher absolute value? So which number in general is bigger? Well, in this case, 8 is generally the bigger number. And since my second term is a plus, that means the 8 is going to go here. And since the 8 goes there, the 6 has to go here. And then put the C in there because we only have a C value of 1. And it looks like we're done with this one. And we can check it to make sure it works out. C times C is C squared, okay? Outside number, so we're using FOIL. C times negative 6 is minus 6C plus 8C, or 8 minus 6 is 2C. So that's how we get that term. 8 times negative 6 is negative 48. So everything works out here. And again, don't be afraid to check them. And remember that one of these is going to have to be negative. So this negative on these ones could be any one of those numbers. A common thing that some students might mess up with this one would be that they would probably put the number or the sign in the wrong place. So that's a very easy thing to do. And that's why I say you should check all of your work. Check it, all right? If you check it and you notice something's not quite working out, change something. In this case, maybe we change the sign or change the number and try it again. Don't be afraid to try it again, all right? Nobody ever gets everything right the first time, all right? So just learn that as a life lesson. If something doesn't work or doesn't work out, try something else. Or if it was a pretty good idea, but you just messed up on carrying it out, then I guess you could try the same thing over again. Anyway, let's go ahead and go to this one here. So I'm going to go ahead and start with the 2 parentheses. Now I need 2 numbers that multiply to 72. So I need 2 numbers that multiply to 72. Now, since this is also a negative, I think it'd probably be helpful to make a list again. So 1 times 72, 2 times 36, 3 times 24, 4 times, and this is just, you could probably easily do this on your own, fairly easy. 4 times 18, 5, okay, I cannot multiply anything by 5 to get 72, so I'm going to skip that. 6 times 12, and I'm trying to find them with a difference of 1. So right now it doesn't matter which one is positive or negative, it just has to have a difference of 1. And 6, sorry, we already did 6, 7. So I cannot multiply any number by 7 to get 72. So 7, 8, let's try 8. So 8 times 9 is how you get 72. So this is going to be the one we're looking for, because if we look at it, it's got a difference of 1. Now, think about it this way. We know that 8 times 9 is 72. So I can go ahead and put 8 in here. And then I can put 9 in here. Now, because they are negative, I usually put the sign in first, all right, because one of these is a plus and the other is a minus, or one is positive 9, the other is, well, it could also be negative 9, but one of them has to be negative and one of them has to be positive, all right? It just has to be. Now, I could have negative 8 and positive 9, or I could have positive 9 and, oh wait, no, I ended up doing the exact same thing. I could have positive 8 and negative 9. So what if this was negative? What would we get? Well, we would get positive 1, but I need negative 1. So that's not it. What about 8 minus 9? I get -1. And there we go. That is the -1 we are looking for. So that means +8, -9. So +8, -9. And here I can just go ahead and throw in my remaining value here, which is n, because our f is the first one. N times n is n squared. And there we go. We got that one done. So again, I know sometimes that looking at this, you might be thinking, oh man, all that looks like a lot of work. It's really not. You're just making a list of all the numbers that you can multiply to get this one. And a lot of times actually, when you get to doing a lot of these, sometimes you can almost just spot it. I don't know how. You get like a sixth sense or something about how to get these things. And I don't know. I think I can kind of almost guess the first time I look at it what numbers it's going to be. And I don't know. It's just because I've been doing this so long, there's probably some pattern that I can use to get them. I kind of have an idea of what it is, but it's a whole nother thing to teach. So again, let's just go ahead and just stick to things being simple. All right, so in this case here, I have, and let's go ahead and start with our signs. So start with the last term and look at the sign. This means they are, well, they're the same, all right? So keep that in mind. They are the same. They could both be positive or they could both be negative. If it is the same, they are the same as whatever the first one is. So in this case, since my first number is positive, that means they are both positive. And sometimes I'll get students that will say something like, well, if they're both positive, then they're both positive. And that's a gross simplification, which is true in this case, but is not true in the other three possible cases you could have. They could both be negative, they could both be positive, or you could have one negative, one positive. So you got to consider all of those possibilities. Now, this one should be an easy one. Think of two numbers that multiply to 36, but if you add those same numbers, you get 12. All right, so you probably already got it. 6 times 6 is 36, but 6 plus 6 is 12. So that's 12 is my middle number. And we're pretty much done with this one. Let me go ahead and just fill it in with the a value because we have a square. And that makes things a lot easier. Now we could also go a step further in this case here. And when we were doing the completing the square or completing the, what was it called? Perfect square trinomial. And this is also another kind of case too. Anyway, so instead of writing it twice, a plus 6 times a plus 6, I can just put a plus 6 squared. Actually, you would read it as the sum of a and 6 squared. But this is a slightly better way of writing it. All right, let's go ahead and move on to this one. And I'm going to go ahead and start with the 2 parentheses. Now, if I were writing this out, I'd probably write them a little bit further. But in this case, I can type. So I'm going to go ahead and just type everything. Now I need two numbers that multiply to 1, but if I add those same numbers together, I'm going to get -2. So in this case, 1 times 1 is the only thing we can do. But again, I keep telling you guys, focus on the sign first, because this is one of those examples where someone's going to say, oh, it's +1 + 1. No, it is not +1 + 1. So look at the sign, it's a plus. That means they are the same. If they are the same, they will be the same as whatever the first one was. In this case, the first operation is a minus. So that means these are both minuses. Now I can think of what two numbers can multiply to 1. Now, -1 times -1 is +1. But -1 combined with another -1 is -2. So that's how this middle term is going to make both of these a negative. So again, that sign does make a difference. And in this case, it looks like I'm going to end up with another square group. since they're both exactly the same thing on both factors, I'm going to combine both of them and just make it an easy, well, there's two of them now. All right, so let's go ahead and move on to this one. Now, this one's a little bit different because one of the other first things you should do when you come across a trinomial with an a value, the first thing you should try to do is look at all three terms and see if you can take out a greatest common factor from all three of them. So 2, 16, and 40. Those are all even numbers. If they are all even numbers, before we even begin, we're going to remove a factor of 2 from all of those numbers. So there you go. Oops, I said to remove a factor of 2, so that means we got to divide this by 2 and divide that by 2. So you can see we divided all of the numbers by 2. Now what we have to do is we also have to take this trinomial, the k squared minus 8k minus 20, the new one, and we're going to have to factor that one. So I'm going to move this over here just so I have more space. Now, if you were writing this, you could probably write it a little bit smaller so you could fit it under here. But in this case here, I'm going to focus entirely on the trinomial first. So let's focus on that. All right, so I need two numbers that multiply to negative 20. Now, if it multiplies to negative 20, that means one is going to have to be negative because that's the only way to get a negative from multiplication. So that means one is positive, the other is negative. So there we go. We have this thing before we even start out. Now, since one is positive, we're going to have to subtract one from the other to get 8. So we're not combining them like, you know, two numbers plus each other gives us 8. One is going to have to be subtracted, so 20. So if I ask someone to think of two numbers that multiply to 20, the first thing they're usually going to say is 4 times 5. Which, if that was true, I'd have 4 minus 5, which is negative 1, or 5 minus 4, which is positive 1. So it's not that one. So let's try a different number. You could try 10 and 2, which is probably the next thing that's going to come to your mind. And 10 minus 2 is 8. So we got the number right, but the sign is wrong. 10 minus 2. So let's try 2 minus 10. 2 minus 10 is negative 8. So that means this is a negative 10 and this is 2. And let's check it really quick again using our life method. 2 times negative 10 is negative 20. Works out. 2 minus 10 is negative 8. Also checks out. Very good start. Our k value, or sorry, our a value, which in this case is k, is just plain old k. And there you go. Now we have factored it out. Now, one important thing about factoring, like I said, we're not dividing. When you divide, numbers get smaller. You get fewer numbers. In this case, this 2 is still there. Nothing was done to get rid of it. Like I said, it's like moving furniture around a house or in a room. You are not getting rid of anything. You just moved it. And that's all that's happening. So if I wanted to put this back together to make this, I could easily do so. And that's one thing about math too, is it's not always about adding or subtracting. Sometimes it's just changing what a number looks like. All right, so I'm going to do the same thing with this one here. So we notice that we have an a value, and a values are always tricky because when there's an a value, there's two things that can happen. And in this case here, we kind of already know what's going to happen because it tells us here a has to equal to 1. But in this case, it doesn't. So let's take out 5 from all three terms. Take out a factor of 5. So I have 5, 25, and 30. So all numbers are divisible by 5. So this means we can take out a 5. So we're going to divide all the numbers by 5. So in this case, I get z squared minus 5, because 25 divided by 5 is, well, 5. Now 30 divided by 5 is 6. And there we go. Oops, oh, almost forgot the x here, or the the z in this case because I had 25z and all of a sudden it wasn't over here. Now it should be a trinomial, which this is. So in that case there, I would have almost made a mistake. Now I'm going to go ahead and get my two bubbles together. Now I need two numbers that will multiply to 6. But again, I want you to focus on the sign first. That 6 is a positive. If it is positive, that means they will be the same. And if they are the same as whatever the first one was, which in this case, the first sign is negative. So that means both of these are going to be negative. So what number can I multiply? What are two numbers I can multiply to get 6? But if I combine those same numbers, I get -5. So we could try 1 and 6. Now, if I had -1 and -6, that would multiply to +6, but it would add to -7. So it's not 1 and 6. Let's try 2 and 3. So if I tried 2 and 3, okay, so -2 times -3 is +6. Works out. -2 minus 3 is -5z. So that also works out. So we got it right. Now let's go ahead and fill in our first number. And I'm also going to not forget this 5 out front. And there we go. Now it's been factored down completely. Whew, okay, so we got it. That's all of them. Let's get ready to move on to the next one. But again, having an A value is a bit tricky. So like those are the only ones that I think most students would have trouble with. But what do you do if you have an A value that just won't go away? Like in this case, we made it go away. Now, what do we do? Like in this case here, where I have 2, 15, and 18. I cannot divide all of them by 2 because 15 cannot be divided by 2. All right, so in this case, we're probably going to have to do a little bit of work. So for this one here, I'm pretty sure we're going to end up with some fractions. So I'm going to do the problem like this. So now this is the way most of them would look if we were working on them, is start off with 2 parentheses, and I'm going to leave some space in there for me to write. So it's this exact same thing I did, but when I type it, sometimes those parentheses will move apart. So I need 2 numbers that multiply to 18. So think of 2 numbers that multiply to 18. Now in this case here, be careful because again, there are better methods that you can use to multiply them. And let me think if I can remember a quick way to do this. I think it's called AC method, and I kind of mentioned it a little bit before. Actually, in this case here, and that's the reason why these are so tricky, is because what I'm going to do is I'm going to give this 2 to the 18. So x squared minus 15x, and I'm going to put it right here. 2 times 18 is 36. And I think this way is a little bit easier. I mean, you could also solve by trial, but that would mean pick some numbers, work it out. If it doesn't work, try something else. And you have to keep changing numbers, changing signs until eventually you get where you need to. So I think this is a much better method in the sense that you don't have to keep guessing, because I know some students, they don't like to guess because they think it makes a lot of work or something, I don't know. So, and from here, you would factor it kind of normally. Now we're borrowing the 2 here. At some point, we are going to have to give it back. So think of 2 numbers that, well, actually, let's look at the sign first. This is a plus sign, which means they are going to be the same, and they are both going to be the same as this one. So we know they are both going to be negative now. Now think of 2 numbers that multiply to 36, but if I add those same numbers together, I get 15. And you could just pick some numbers like 6 and 6, all right? So 6 times 6 is 36, but if I add them together, I get 15. So let's try a different set. What else can 36 be divided by? 36 can also be divided by 12, maybe? Well, actually, let's go ahead and make a list really quick because you know what? I'm kind of at a loss in this case too. 2 times 18 is how you get 36. 3 times 12. Oh, there we go. 3 times 12. That's got to be it right there. Yeah, that's got to be it. So let's go ahead and put 3 and 12 here. So -3 times -12. So negative times negative is positive, but negative added to another negative is a bigger negative. So that works out. -12, -30, put them together, you get -15. Now here's the hard part because we took the 2, right? We got rid of it. Well, we didn't really get rid of it. We just moved it somewhere else. Now we're still going to have to bring that 2 back. Now, to bring the 2 back, I'm just going to divide both of these numbers here, the numbers that we got in our factor bubbles. So now it's time to get that. Why did I put one? I put 3 in one of them. My bad. We're going to have to get that 2 that we multiplied back. All right, so now we have to multiply it back. So in this case here, I get x minus 3/2 as one of the factors. This is normally not the way you would have it. You would normally not put them in a form like that. I'm trying to remember, how was it we get rid of that? I think to get rid of this, you would just multiply both of them by 2. So multiply this by 2. And that gets rid of the fraction here because, you know, if I multiply 3 times 2, I get 6. 6 divided by 2 is 3. So we get -3. So basically, I just double both of those. Now, this next one, luckily, is going to be a lot easier because it's just x minus 12 divided by 2, which is 6. Oh, okay. Now, again, but anyway, let's check it. That's what I'm trying to get at, all right? So sometimes I have to check these too. 2x times x is 2x squared. Oh, right here, 2x squared. All right, we're trying to get back to the original. All right, outside is 2 times -6. So that would be -12x. -12x minus 3x. That would be -15x. -3 times -6 is +18. So this works. Okay, good. I remembered. So that would mean that this is our final factored form. That is the complete factored form of this method here, this thing. Whew, okay. Now again, I do have that same issue here because I have a 5, and we should check to see if we can divide all 3 terms by anything. 22 cannot be divided by 5, and 48 cannot be divided by 5. So in other words, I cannot get rid of this 5 here, which means that I am going to have to do the same thing, which is okay though. It's good, right? So let's pay attention to the process and let's hope it goes a little bit smoother this time. I am going to give. Later, I will have to take. And 48 times 5, I think I know what it is, but 240. And don't be afraid of big numbers like this either, okay? So even though they're really big numbers, okay, you're not gonna have to do a whole lot. So now I need numbers that can multiply to 240. So in this case, I'm probably gonna have to just pick some numbers. Now I'm trying to get these 2 numbers so that they can get to 22. Now here's why it's important to look at the sign first. This sign tells me that they will be different. One will be plus, the other will be minus. Now, this simplifies things because now I know I'm not going to add anything together. I'm going to subtract one from the other. So now this eliminates half of all the guesses I would normally have to take. And that's why I tell you, do the sign first. All right, so let's pick a number. Let's go with, I wonder if 240. I want numbers that are kind of close to each other. So 1 and 240 are very far apart. 2 and 2 times 120 is very far apart. I'm trying to find numbers that are 22 units apart. And just to show you my process too, I'm going to go ahead and move over to the calculator here. So 240 divided by 10. Let's try 10. So 10 times 24. Now, I could go 24 minus 10, and that would be 14, but I'm trying to get 22. So I know it's a number somewhere between 10 and 24. 240 divided by 12. 12 minus 20 was not quite 22. So we got to try some different numbers. Let's try, okay, so it's got to be some, let's see, 240 divided by 25. Okay, that's not a whole number, so this would not work at all. 240 divided by 8. Now, 8 and 30 do have a difference of 22, because if I subtract 30 from 8, I will get negative 22. But we don't need negative 22, we want positive 22. So at least we know the numbers. We know that the numbers are going to be 8 times 30. Okay, 8 and 30 will multiply to 240. But again, is it gonna, well, actually, it would be this way here because negative 8 plus 30 is 22. So now we know that this is going to be the negative and this is going to be the 30. And with the calculator, sometimes you just got to keep playing with it until it works, so you get the right number. All right, now we have our numbers and we're pretty sure this is what we would need to. And if we're not sure, we could check it again. But in this case here, remember, we gave a 5. Now it's time to take it back. So P plus 6 is our first group. And over here, okay, so with this case here, we're going to do the same thing that we have here because 8 does not divide nicely by 5. So what we're going to do is we're going to multiply both of them by 5. Multiply this P by 5, we get 5P. Multiply this by 5, we cancel out the bottom and we get 8. There we go. Looks like we're done with this one, and if we're not sure, we can always test it again. So P times 5P is 5P squared. 8, or negative 8, times P is negative 8P. 6 times 5 is 30P. 30P minus 8P is 22P, so that works. 6 times negative 8 is negative 48. So there you go, that one works. So all three of these work. And again, don't be afraid to check it. Here, it's more important that you check it than it would be on most normal problems because, again, this is kind of a lot of steps to go through. And if you're not sure, it's really easy to make a misstep somewhere. All right, so let's go ahead and go to this one here. So I have 3 times 40. So again, I cannot divide all of these by 3. So I'm going to have to go with 3 times 40. In this case, it's just 3 times 4, which is 12. Put the 0 back on because of 40 instead of 4. And let's go ahead and get our bubbles. And now, looking at the sign, we can already tell that this is going to be different. because the only way to multiply to get a negative is if one is positive, the other is negative, and it doesn't matter which one goes first. I think my habit is just to put the positive one first. Now think of two numbers that multiply to 120, but if I subtract one from the other, I should get negative 19. So what numbers could I put in there that will work? So again, let's make a list. So for now, let's just ignore the signs. 1 times 12, 120. I could go 2 times 60, 3 times 40, 4 times 30, 5 times 60. But I'm thinking we're going to need two numbers that are closer together. 5 times 60. Maybe we could try 10. Let's try 10. 10 times 120. Now 12, remember I need to subtract 1, so that is not going to be negative 19. And this is kind of a hint because I know one of them is going to be odd, actually. I think one of them is going to be odd because the only way to get an odd number adding is, because if you add two even numbers, you're going to get an even number. If you add two odd numbers, you will still get an even number. So we're going to have to try something else. Let's try 15 maybe. So 120 divided by 15. Did I push that right? 5 and 8. Okay, 5 times 8 is 120, but 15 and 8, let's add them together. That doesn't work. So it's a number very close to 15. I don't know if 13 is going to work out. Let's try 5. So 120 divided by 5 is 24. Oh, okay, there it is. Wait, no, wait. 24 minus 5 is 19. Okay, so we got the number right. But I need to know which one of these will, so I know this is going to add up to 120. If I multiply them, it's going to come out to 120. Now I need negative 19. 5 minus 24 is negative 19. So there we go. We have our two combination of numbers. So this means 5 is this number and 24 is this number. H and H. Okay, now since we gave the 3, we're going to have to divide by 3 now. So let's go ahead and divide by 3. So in this case here, 5 does not divide by 3, so I'm just going to multiply both of them by 3. Now, this is not really going to change anything, because I could probably imagine some people asking, well, how did this become that? When dealing with fractions, sometimes you're not actually dealing with a value, but you're kind of dealing with a relation. But it does work out, though. I guess that's all you need to know for now. I mean, I could tell you exactly why it can do that, but we'd be here like all day if I had to. Now, I'm not sure how long I've been working on this because actually the bell rang not that long ago. So actually this is 3rd and 4th hour. And I started kind of late, so I don't know exactly what the time would be. I don't know. I guess I should just finish it. We have 26. I'm looking at the packets. We got like 10 more after this. Hopefully these next ones won't be so bad. All right, so I'm going to go ahead and do this one here. So 2 times 12. These first two signs are going to look kind of standard, but 2 times 12 is negative 24. Now again, when I start my double bubble, this is the first thing we look at is the sign. So again, Loif, last thing, look at the sign. Different. All right, so that narrows down what we're looking for. It takes away a whole bunch of guesses. I mean, we could sit here all day and guess, but so far with each of these, we've been able to get them right the first time, almost every time so far. Now I need two numbers that multiply to 24. Now, if I subtract one from the other, I should get 5, which means one of them is going to be an odd number. And I think I know which one it is. 3 times 8 is 24. Now, if I have to subtract one of them, I could go with 3 minus 8, which if I did that, 3 minus 8 would be -5. So it's not that one. So we're going to need 8 minus 3 is +5 because it has to match to this one here. So it's not this one. So we know it's 3 and 8, and the negative is on the 3. Throw in our first term, which in this case is x squared. Now remember, we gave a 12. Now it's time to get it back. Whew, man. Yep. This one is going to be a bit of a tough one because well, we're going to simplify it first, I think is what we're supposed to do, simplify it first. So 8 and 12, just like you simplify any fraction, you're going to reduce it. Think of a number that 8 and 12 can both be divided by, so that'd be 4. 8 divided by 4 is 2. 12 divided by 4 is 3, so this would be 2/3. And you know what? Actually, what I should have done is I should have just left it here. I think if I just left it here, I think students would be able to still get it. And I don't know if it would make any more sense. I think it would be the equally amount of confusing. But we're going to simplify this part here too. Now to get rid of the fraction, we're going to move this number over here. So that's going to be 3x plus 2 and 4x minus 1. Now, in general, whenever you see a factored trinomial, it's going to look like this. In other words, it's not going to have any fractions. Although I have seen some with fractions. So technically, I guess both could be right, but this way is righter. Okay, fine, more right. Okay, so we got 2 more pages to go. All right, now let's go ahead and move on to the next one. And I think this is more of the same thing. So same directions from here. We are factoring trinomials with an a value. So that's what it means right here, a value greater than 1. And if you look at all of the a values here, they are all greater than 1. All right, from here I'm going to pick up the pace just a little bit. Otherwise, this lesson would probably reach a great length. All right, so let's go ahead and go y squared minus 5y minus, and then let's say 6 times 21 would be 126. Get our bubbles. So remember, we gave 6, so we're going to need to take that back. Signs are different. Now I need 2 numbers that will multiply to 126, but if I subtract one from the other, I get 5. So in this case here, well, let's see, what can 126 be divided? Now, it's always with these larger numbers that I'm always like, okay, well, what can we put in there? 2 times 63, 3 times, where'd my calculator go? 126 divided by 3 is 42. So 126, can I divide it by 4? So that'd be, nope, cannot divide by 4. Cannot go with 5. Let's try, oh, 6 will work out because it's just going to be half of that. So 6 times 21. But let me double check that. 6 times 21 is 126. So that is one of the possible factors. 126 divided by 7 is 18. 7 times 18. Okay. 18 minus 7 would be 11. So we're getting closer and closer to 5. And 8. 8 I don't think works out because 4 would have to work out in order for 8 to work out. 9, can I go 126 divided by 9? Which it's 9 times 14. Now, 9 and 14 do have a difference of 5, right? Because I could go 14 minus 9, which would be 5. Or in this case, I think it'd be better to go with 9 minus 14. So this means that the negative is going to go here and the positive is going to go here, the 9. Put y here, divide both sides, because remember, we gave a 6, now we must take a 6. Simplify the fraction first. So this would be 3/2. And over here would be 14 divided by 6. So it'd be 7 over, because they're both even, 7 over 3. Let's move the fraction over from this number to that number here. So in this case, I get, I should erase some of this, 2y plus 3 and 3y minus 7. So there we go. That should be the final answer for this one here. Yeah. Okay, that one was a messy one. Let's go ahead and do this one. All right, now with this one here, I could do the same thing. I could go 16 times 54. But that's going to be a pretty big number. Now, just because I don't want to deal with super huge numbers like that, I am going to, I'm gonna do what we did on the first one, and I'm gonna take out a number. So let's see, what would this be? What would happen if I divided everything by 2? 2, so divide this by 2. 54 divided by 2 is 27. All right, and then check these numbers, make sure I don't have anything else I can divide out of them. Which it looks like there is nothing I can divide out, because I could divide this by 3, divide this by 3, but 8 cannot be divided by 3. I could divide this by 2, divide this by 2, but 27 cannot be divided by 2. So I think 2 is probably the best number I can take out. All right, now I'm gonna have to do the give thing. So 8. 27 times 8. Uh, 27 times 8 is 216. I just had an almost deja vu right there because of this. And now I'm going to need to get two numbers that multiply to 216, but would add to 30. So 2, and then I'm just going to put double bubble here. And again, this helps out a lot. You wouldn't think of it, but it does help out a lot, because if we check the sign, they are different. So now I know that one of them is going to be a subtraction, the other is going to be a positive number. And they must come out to 30. So what two numbers can I multiply by 216 to get 30? So let's try it. I'm going to start off with 10, maybe 10 times, no wait, 10 is not going to work out. I could try 3, but well, okay, so let's try 3 times what gives me 126, 216, sorry. 216 divided by 3 is 72. And they need to have a difference of 30. Now, I could probably try 9. 72 divided by 3 would be 24. 9 and 24, really close. Really close. What I'm doing is I'm taking one factor from one to get to the other. And in this case, you might have to make a big list. I'm using a few shortcuts here. So I could go with, I'm going to take out 2, so divide this one by 2. Times this one by 2. And that's kind of what I did right here. Divide this by 3 times this by 3. So there you go. I'm kind of focusing my guesses a little bit better. So I'm able to get to it much faster. So it looks like 18 and 12 might be the number I'm looking for. Well, if I added 18 and 12, I would get 30, but we're not adding them. One of them is being subtracted. So actually, if I did not catch that these two should be different signs, we would have gotten one of them wrong. So I'm going to double this one here, 36, and then I'm going to half this one here. And I get 36 times 6, and just to double check it, 36 times 6 is 216. But remember, one of them has to be subtracted. And in this case, 36 minus 6 is 30. So that means it has to add up to this number here. So that means this one is 6, this one is 36. M. Make that M a little bit better. Okay, pretty tough one. Now remember, we gave a 16. Now we should take it back. So take back 16. Now I'm also going to, let's see, M, and then 36 divided by 16. So that does not divide, so I'm going to have to reduce it. So that would be 18 over 8. 18 over 8, but 18 over 8 can be simplified again. 18 over 8, so that'd be 9 over 4. So 9 over 4. And here I would have 6 over 16, so that'd be 3/8, or 3 over 8. 3 over 8. Oh shoot, you know what? I just noticed I did something. This is not 16. I was looking at the original number. It should actually be the original number should have been 8. Okay, luckily we didn't finish the whole thing. So let's see, 36 over 8. So that divide them both by 2. So that'd be 18 over 4. 18 does not divide by 4. 18 over 4, that'd be 9 over 2. M, and then here would be, this one's an easy one. This is 3/4. And again, I'm going to do the same give the fraction thingy that we did earlier. So the 2 stays, 2m plus 9. So again, move the fraction from here to there. 4m minus 3. And I'm pretty sure that's it. I really should check it, but man, oh man, you know what? I shouldn't be lazy either. 2m times 2m, 2m times 4m is 8m squared. Now, what's kind of tough is I need to get back to this number, but if I go back to here, you know, that'll save me from having to multiply this part by 2 as well. Let's see, what have I got here? Next one would be negative 6m and 36m. So 36 minus 6m would be 30m. 9 times negative 3 is negative 27. So if I would get to this step and I just multiply all this back out to get to here. So, whew, okay, there you go. I talked myself out of being lazy. All right, sometimes I have to do that too. I wanted to just leave it like that, but sometimes we just can't leave it like that. All right, so I can't divide all of these by the same number. So 9 times 4 is 36. And this one should be a much easier one. In fact, they're going to be the same number, right? So they're both going to be the same. They are both going to be the same as whatever the first one is. So that means they're both going to be negative. So 6 times 6, is, well, negative 6 times negative 6 is positive 36. So that works out. Negative 6 combined with negative 6 is negative 12. So that also works out. And in fact, I don't think there's really any checking with this one. I'm almost certain that we got it. But remember, we gave a 9, so we have to take a 9. And in fact, I don't have to do this twice. I can just do this one time. And if I simplify it, I get 2/3 like that. And again, let's get rid of this fraction. Just take this number and put it in front of this number here, 3x minus 2 squared. And that one, like I said, was actually a pretty easy one. I was actually kind of worried about that. All right, let's go ahead and move on to number 20 now. So with number 20, wow, we got a pretty big number here. So let's look at all three of these numbers and let's try dividing them all. I'm gonna go straight for the big one right now. I'm gonna try to divide all of them by 8 because I know 56 can be divided by 8. So my question is, can 96 be divided by 8? Which it can. It's 12. So that's what I'm gonna do. I'm gonna divide all of them by 8. And that was 12. There you go. Now I have much smaller numbers to work with. Good. I don't want to have to deal with a big number like 216 again. I mean, you can do it, right? You can make a list, or you can kind of do like an educated guess on these. But I understand that it does take a while to keep doing this. So let's go ahead and keep going. And in fact, actually, I have no A value right here. So I could just use regular, I think I could just use a regular problem from here. Check your sign. They are the same. They are the same as whatever this one is, so they are both positive. Two numbers that multiply to 12, but will add to 8. 3 and 4. This one was almost too easy. I'm almost worried about it. And I did nothing weird, so that's got to be it. That's got to be it. Yeah, that's got to be it. I can't see anything else that we should have done or anything like that. All right, and then in this case here, I should box these, but some of these are kind of out of the way. So when we're done, we got to box them so that we know that this is the final step in our factoring. Just because sometimes I know some students would like to check these, and then they're going to put more work underneath, checking it to see if it goes back to that original problem. And, it's kind of hard to find the answer. So especially on these ones, I'd say let's go ahead and box them. All right, so we finally made it to the last slide. So let's get it over with and see what happens. Now, these are a difference in squares. This is actually a special case where you can use a shortcut. Let me see if I should both, let me see if I can right away. Both terms should be square numbers. And there should be a minus. Where can I put that? Sorry, warrior guy, you're gonna have to, well, I can't get rid of it. Gosh, all right, but these are the two rules. So this is the quick way of finding out what you can use. So again, I don't want to make it too small because you still got to be able to read it. But I also don't want anything to be blocking it out. So I'm just going to put it right there. So both terms should be square numbers, and there should be a minus between them. That's why it's called a difference of squares. Difference meaning like subtraction, and squares meaning square numbers. And again, this one's actually going to be kind of fast, and I'm kind of worried about covering it a little too fast. So let's start with the same thing. Now, these ones are also different because there's only two terms. And you might be asking, where did the middle term go? So I'm gonna kind of answer that question with this first one here. So think of two numbers. Now remember, this is A value and this is C. This means we are missing the B value. There is no B value now. So where did it go? Where could it have gone? Was there ever one? Now check the sign. So this is a negative. So that means that these two things are going to be positive. I just used the regular thing, this regular old life method that we've been using this whole time. Two numbers that multiply to our C value, positive 2 times negative 2 is negative 4. But if we check it trying to use our FOIL method, so let's use our FOIL method, x times x is x squared. Now we're checking it. We're not, this might be our answer. So let's see what happens. X times negative 2 is negative 2x plus 2x right here on the inside. And our last term is negative 4. You're also going to notice that my two inner terms are the same but opposite. It's the same number, opposite sign. Positive 2, negative 2. 2 minus 2 is 0x. 0x is gone, which is why you don't see it here, because it canceled out. So this usually means that the B value is the same but opposite. That means that this is actually the right answer. Now, the shortcut that I'm going to talk about is going to kind of be the same thing. So they're both square numbers, y squared and 81 is a square number. So what two numbers can multiply to get 81? You probably already would have said 9 times 9 is 81. Now, because it's a negative, one has to be negative, the other has to be positive. Don't forget, this is the second sign or the third term, the C value. And that would mean that this is a y here and there. And we could check it, and it would work out. So again, let's move on to number 23. Both terms should be squares, and there is a minus. So there's a minus. 9 and 25 are both square numbers. So let's go ahead and take the squares out. Now, what makes this one tricky is we have high powers of x and y. So we know one should be plus, the other should be minus. And now I'm looking at this, I'm thinking I should have gotten a bigger parentheses. You're going to need a bigger parenthesis. So 3x. So 3x times 3x is going to make 9x squared. And then here, two numbers that multiply to 5 is, 25 is 5 times 5, y. Now they need to multiply to y to the fourth. So that would mean y squared. And they should be the same, because if I were to multiply them out, all right, so 3x times 3x is 9x. No problem there. 3x times negative 5y squared is going to be 15xy squared. Inside term here, positive 15xy squared. Canceled. All right? Just like cancel culture, it's gone. That's why it's not there anymore. Actually, so we got it. So you're just taking you're in a way just taking the square root of both numbers. And in fact, that's actually a really good way to explain it, because you're just taking the square root of both numbers. So just imagine square root and square root. So let's put our parentheses down, plus, minus, take the square root. Square root of a square, m squared is just 1, n squared, take the square root, you just get one of them. 49, take the square root of that, you get 7. And there you go. And you can check it again, make sure it works out. But if I did, it would be 7mn minus 7mn. Okay, so both numbers should be squares. Well, 72 is not a square number because 72 is 8 times 9. So if it was 81 or 64, then it would work out. So what's going on with this one? All right, so what we're going to do is take out a factor of 2 from both of these. Divide this by 2, you get 36. 36r to the 6th power s squared. So I took out a 2 from both of these numbers. I took out a factor of 2. In other words, divided both of them by 2 and put the 2 out front. Now remember, you gotta put this number out front. Anytime you do this, you're not dividing. We're making numbers go away. That's not what you're doing when you're factoring. It's like when you factor, you're like taking it apart. It's like taking apart a machine. If you take apart a machine and you lose a piece, you can't put that machine back together. Now from here, let's go ahead and take the square root of both sides. Square root of 36 is 6. R, now I'm going to split it down the middle. And then here, plus, minus, S. Just split the variables right down the middle. All right, and it looks like we're going to have to do the same thing with this one here, divide. Actually, you know what? I'm going to have to take out a B, because in this case here, the B is odd. There's an odd number of B's. So this one has a B, that one has a B. In fact, you know what? I could also take out an A as well while I'm here. Okay, 32 divided by 2 is 16. We had 4 A's, take 2 of them out, you're left with 2 A's. B is gonna, no wait, you took out the B, so it's not gonna be there. Now, are these square numbers? Well, 16A square is definitely a square number. 16 is square, A square is square. What about 1? Is 1 a square number? Yeah, it is. 1 times 1 is 1. So therefore, 1 is technically a square number. So let's take the square. Now, here we're done with this part here. This part, we're done with it. Let's focus on the parentheses. So 1 times 1, and again, different signs. Square root of 16. Split the A's. There are 2 A's, so each one gets 1. I was a little bit short on the explanation for this one, but actually I think it works out pretty well, because even though I didn't have to explain a whole lot, I hope it really gets the message across on how this is done. Kind of like I saw a tutorial the other day about like, it was like modeling clay or something. And I was like there was no talking in the whole video. There was nobody saying, well, welcome, I'm going to be talking about this and that, and I'm going to show you the steps and talk to you about, no, he didn't. It was just like absolutely no dialogue in this video the other day that I watched. And everybody in the comments was like, you know what? He didn't say a thing, but I understood. So hopefully that's kind of what you get here. But yeah, these ones are a little bit easier once you know the shortcut. So let me just continue that right here. So both terms should be square numbers and there should be a minus between them. Just take the root of both numbers. And you should also remember that if they're not square numbers, see if there's anything you can divide out factoring, or greatest common factor to take out from both of them. Take the root of the terms and then make your double bubbles with one positive and one negative. And that's it. Anyway, this video has gone on long enough. I'm going to go ahead and end it right here. So I will see you guys later. Thanks for stopping by. Bye-bye.